On this episode of AviatorCast, wind-wise tips for flying airplanes.
Welcome, aviators, to another episode of AviatorCast. Load up your flight bag with useful flight training topics, interviews, and aviation passion. Let's kick the tires and light the fires. Coming to you from Angle of Attack Headquarters in Homer, Alaska, here's your host and flight instructor, Chris Palmer.
Welcome, aviators, to another episode of AviatorCast. My name is Chris Palmer. It's great to have you here for another subject, something I hope that you find useful. So I've kind of been doing some more mindset podcasts recently with don't quit flight training, some of the things that could help you in your training, like the process of private pilot, instrument, commercial, CFI. I did a podcast on each one of those licenses, kind of how to avoid burnout and how to build your structure. But I've also wanted to get into some of the more nitty gritty, just learn something type of episodes. So I'm going to be doing some more of those as well. So I want to talk today about wind-wise tips for flying airplanes. Just this thought of viewing wind holistically in the flight environment, because it's something that a lot of people don't pay attention to or think about as they are doing their flying. And it's super important and comes up in a lot of different ways, especially during takeoff and landing, but can also come up in mountain flying. You see it when you're doing your ground reference maneuvers. Ground reference maneuvers are basically a way of correcting for the wind. That's why they exist. They know you can fly the airplane in different ways. They just want to see that you know how to correct for the wind while you're flying. So in this podcast, we will look at what wind is, dispelling myths and defining wind. That's kind of an interesting subject. Seeing the wind through indicators and visualizations. I think you guys will find some great tips there as well. Feeling the wind by applying visualizations to actually controlling the airplane. So taking what we've seen and actually doing something about it. And then we'll break down the wind in different phases of flight, from taxi all the way through up and down to a landing, and what we are looking for. All right. So let's dive right in. So what is wind? So a lot of the times when we're thinking of wind, especially when we're planted with our feet on the ground on a gusty day, we feel wind pushing against us. Some of us might have even been in storms strong enough to lean against the wind and feel that push of the wind against us. We might even feel it at our back, or like it's pulling us, or we kind of feel that resistance of the wind. However, in an airplane, it's a lot different. Once we're in the air, the air is a body of, or a mass of air that's simply moving. So it's almost like a cube of air. If you can imagine that your airplane is just frozen in the middle of this ice cube of air, and it's just being moved along as part of this weather system, that's really what is happening. The airplane doesn't know that it's windy, okay? At least not when it's not on the ground. When it's in the air, it's just along for the ride. So there's a good analogy about this in the book called Stick and Rudder. And when I read this, it just blew my mind that I'd always been looking at wind in this sense of push and pull. And we'll talk about that a little bit later, because there are some situations where we want to be thinking of it in that way. But when we're in the air, we need to be thinking as if we're almost on this train, if you've ever been on a train before, okay? So we're on a train, and we know that we're moving along the track, but we are not feeling any resistance. We don't feel the wind resistance of what's happening. We can go forward, we can come back, we can sit down, we can go side to side, but we don't feel any resistance, but we're still moving within that space. That's essentially what's exactly going on in the air as well. We have this air mass that's moving along, and our airplane is in that air mass, okay? Even though we're pointing in one direction and going, we're actually moving along with that air mass a little bit as we're going. So if we have a headwind, well, and we're not moving along as fast as we want to, it's not because we're actually getting pushed. It's because that air mass is moving the opposite direction we're moving, and so we're not making the progress as well. If we have a tailwind and we're moving down, well, it's because that air mass is moving with us, and we're getting there faster. We're getting a little extra, how would I phrase this correctly? We're getting a little extra bonus. And I don't want to say push. I don't want to say speed. because really we're just moving along with that air mass as it moves us along. So that kind of dispels the myth of the push and pull that we usually feel on the ground, in that we are just kind of along for the ride when we're up in the air. We don't have that friction on the ground, that resistance that has us planted. We're just moving along with it. Now, of course, to counteract that, we can do certain things, and we'll talk about more of those methods later on. But we are just along for the ride in the air in this cube of air, okay? So that is wind. That's seeing the wind and understanding holistically what's actually happening, kind of thinking of things in more of a cruise phase of flight as we're moving along, how that's working. So that's the big picture of how wind actually works. Now, of course, we want to be able to not define the wind, but we want to be able to see the wind as well. Seeing and visualizing, I think, are two different things. Seeing is directly seeing, which, of course, we know the air, for the most part, is invisible. And then visualizing is knowing it's invisible, but imagining where the air is actually moving. So we'll separate the two and talk about it. But I want to talk about some of the things that we can actually look at to determine the wind, and then some of the things we can do to visualize the wind. So this is all seeing the wind. So we have our official wind indicators. We have wind socks, which I did a 1 Minute Wings episode on this recently. You can actually tell how fast the wind is going, or the velocity of the wind, by looking at the wind sock. It's in different stages, usually increments of 3 knots, if I remember correctly. And you can see it in different stages. So you can actually look at a windsock and how well it's extended and know how stiff the wind is. So we have wind socks as an official indicator. We have a tetrahedron, which is actually kind of an airplane looking thing with a tail and everything. And we have a wind triangle, which more points toward the wind. So a wind triangle. And then around that is the segmented circle. And that'll actually show you from above. It shows you what direction the pattern would be. So if you had no charts or nothing else, you could fly over an airport, assuming it had a segmented circle, and see which pattern entry and everything you should do, or which direction the pattern should be for different runways. Of course, I think windsocks are one of those things that we don't see a lot. We end up, and this is the next tip, we end up getting the weather on the radio. Say that's through the ASOS or AWOS or the ATIS or the AFIS. We get that weather, we hear it over the radio, we just go by that wind direction. But I think a lot of the times we fail to actually just look at the windsock as we're taxiing out, or look at the windsock as we're landing, as kind of a final verification of the angle where it's at. And I think by doing that, we start to get more into the visualization of the wind, and actually seeing, based on the runway, how strong is it and what angle is it coming at to the runway. Seeing it is really believing in this case. And while we can determine with the automated system or seeing the sock that we are going to take the right runway and do a takeoff with a headwind, landing with a headwind, we'll talk about the importance of that here in a few minutes. While we can determine it early to kind of determine which runway we're going to use, it's a whole different thing to actually look at the windsock. So that's what gets us into visualizations, where that's an official way with the wind indicator to look at the windsock and see what the direction is. But a lot of tools that we use here in Alaska, just because there's a lot of off-airport flying and flying in areas, especially the mountains, where it's good to see how other features are reacting to the wind. Of course, we don't just have windsocks speckled throughout all of eternity here on Earth. We need to be able to look at things like trees and know how much the wind is blowing based on that. Water, how much the wind is blowing based on that. There's a whole not science, but there's a whole method behind reading water. I haven't really learned it deeply yet, but someone was talking about it recently, how things are white capping on the water, how fast the wind is going, the velocity of the wind based on what the white caps look like. So I thought that was interesting. But even seeing the water on a lake, for example, just as an example, if you fly up to a lake and you're looking down on it, there should be a protected side of the lake, especially if there are trees around the lake. If there are just bushes, there's still going to be a protected side, but it might be a little thinner. But what you'll see is that the wind is really calm on one shoreline, and then you'll see the ripples in the water separately. But the wind will be really calm on one shoreline, and that tells you the exact distance or the exact direction that the wind is coming from. Because basically the trees or the bushes are blocking that wind. So the wind comes over, and then it'll finally hit the water several feet ahead or many feet ahead, depending on the obstacle. And then you'll see it. But you can tell the wind based on that. Seaplane pilots, they know that in the water, there's these white streams. I'm not even sure what they're really called, but there's like these white stripes that almost go directly with the wind that tend to happen quite a bit in bodies of water, especially lakes, I've noticed. So trees and water and features in the water, blowing snow or dust, you can tell which direction the wind. Smoke from a chimney top. I don't even have that on my list here, but smoke from a chimney top. All of this becomes really important when you're out flying either in the mountains or flying remotely, and you need some other wind indicators that are helping you determine where the wind is from. And the reason why that ends up becoming really important with visualizing, so again, imagining where that wind is coming from, is because in the mountains, things move like water through a stream. You guys may have heard me say this before. Many instructors do. It's the one analogy we use to show or visualize how air is moving through the mountains. So if you can imagine water or rapids moving through a stream or a river, you can get a little babbling brook that's just a little bit of movement here and there, and it's not moving very fast, and you're not seeing any rapids or any little white water. It's just kind of moving along, moving around things, and then moving all the way up into a huge river that is causing gigantic rapids and billowing up over boulders and creating pools of eddies and what would you call them? What would it be in the water? Anyway, almost like a tornado. I forgot what that's called in the water. Gosh, what is it called? Anyway, so all of these different things that can happen in the water to make it turbulent. Okay, so if you take that visualization and then you use it instead, you use mountains and you say, okay, if it's moving fast, it's moving over this peak, going down. That's going to create a downdraft on the leeward side. And then it's going to go upslope, and there's going to be a wind, an updraft on the windward side. You can start to visualize how and where you should fly the airplane, where it's maybe going to be a little bit more dangerous to fly through the mountains, and feel that out in that way. We also get into things like thermals. So thermals is the convective heat of air, which is basically air moving upward, and that's creating lift from the thermals. So there are really good examples of all this in the PHAK, the Pilot's Handbook of Aeronautical Knowledge, which is free online. It's an FAA document, kind of like a free textbook. But I remember they have a picture in there of an airplane approaching for a landing, and they have a big parking lot where there's a shopping center or something, and that warm concrete from the sun can create a thermal, can create a little bit of a lift, so you might get a bump up from that. But then you go over a lake that's between that and the runway. That lake is going to create a little sink because it's cooler air, and so you'll sink there, and then you might get a little bit more of a lift as you get toward the runway as you're getting over warmer land. So visualizing how all this stuff is moving, whether you're in the mountains or you're locally, is really, really important. Now, not all of you are going to be doing mountain flying, but all of you are going to be flying at an airport at some time or another. And this visualization of winds, I have found, is actually very, very helpful when it comes to airports, when it comes to takeoffs and landings, particularly where we have big buildings that are there. We have maybe even some hills or some little dips or some valleys or rivers that are lower than the airport, or trees where things can move in and around as well in the airport environment that in the critical phase of flight, when you're slow and climbing out, or you're slow and landing, when you don't have a lot of extra energy, can cause issues. Now, if properly planned for, they end up usually not becoming an issue as long as you're not doing something reckless. But you need to be visualizing, everyone needs to be visualizing how air is moving in and around airports as well. At our airport, we have one half of the runway that has most of the hangar buildings there, and it has a lot of the trees that are closer. Just off the side of that is the ocean. And so what happens is we get a lot of wind that's spilling up over the trees, mixing with all the hangars and trees, and then coming down and spilling onto the runway. So it's almost like the wind rushing off the ocean jumps over the little hill we have there and then spills down on top of the runway, plus creating a bunch of turbulence right there. So in really heavy crosswinds or winds, I have found that the best thing to do is actually land halfway down the runway. While it's perfectly possible to land in the first half, I just make it easier on myself. I just play it cool and go down the runway a little bit more, where there's not the opportunity for that air to be mixed up as much. And it's amazing, just a couple 100 yards or a couple 100 feet, the difference that it makes in the landing quality and the feel of it. So I just wanted to bring all that up. We'll bring that up a little bit more here when we talk about some other things. Okay. So that's visualizing the wind. That kind of sets the stage. I need to move a little bit quicker here to meet our half-hour mark. So feeling the wind. You guys have probably heard of crabbing before. If you haven't, crabbing is when we're moving with that mass of air, right? But what we want to do is we want our ground track, so where we're at on the ground, to be going on a certain path. So while we may be moving with that mass of air, imagine a little pencil sticking down through the airplane, and you're going to draw that path with your airplane right where you need to go. Well, that means that we're going to have to turn into the wind a little bit and fly into the wind if we want to keep a track or whatever it is. That's crabbing into the wind, is when we're flying into the wind a little bit to go a specific direction. Ends up being a big thing when you're doing your crosswind landings and takeoffs, and you're going to hear crab quite a bit. It's one of the main things we use in aviation, the terms when we're correcting for the winds on our actual path versus our heading. So our heading might be 180, but because the wind is blowing from 270, we actually have to fly more like 200 to keep that 180 heading. I don't know if that makes sense to you guys, but anyway, we have to turn into the wind to fly that direction. Okay. So that's actually feeling the wind. So controlling for the wind, I'm just going to kind of rattle some of these off, things for you guys to think about, because there's actually quite a long list of things here. So controlling through the wind or with the wind, now that we have an actual definition of what the wind is and that we actually need to control the airplane to do things to get through it, we are ultimately in control of much of what we do. Wind can get to the point where you can't control the airplane anymore. If the crosswinds are too strong or the winds can just be too strong. I mean, can you imagine flying an airplane in a hurricane? Not going to happen. There are just some points where the wind is too strong and you shouldn't be flying and you shouldn't really even be taxiing the airplane. Okay, so I'm going to start from taxi. I'm going to go all the way through to takeoff, climb, cruise, descent, landing, all of those things, and talk about some things to think about. So in the taxi, we have control deflections that we use to make sure that we're turning into the wind so that the wind doesn't catch our wing and push us over. So, or it can actually pick our tail up and push us forward, or it can pick our nose up. It can do all sorts of things. It becomes especially important when you're in a tailwheel airplane because they're a little more susceptible to some of those movements. But there can be a point where taxiing in the wind becomes too strong for your ability to counteract it. And basically, the gouge that is used is you turn into the wind. So turn your stick or your yoke into the wind. You dive away from the wind if it's a tailwind, and you climb into the wind if it's a headwind. Now, if you have like a right quartering tailwind, for example, you would dive away and you would turn into the wind. Okay. So anyway, there's a bunch of different combinations that you'd use as well, if it's a quartering wind or a crosswind or a tailwind or a headwind, and you'll learn about those as you go through, or you can recommit yourself to actually doing that. All right, so takeoff. So we take off into the wind for performance reasons. Now, this is more of an application to that you standing on the ground sort of thing and getting pushed. So we do have a little bit of friction here where actually that wind rushing past our wing is going to create extra lift for us, or at least reduce our ground roll and help us out. So a lot of it has to do with kinetic energy and how fast you're moving across the ground. So if we take off into the wind, well, we get that extra performance. We take off sooner, we climb sooner, all those things. There are some exceptions, but for the most part, we usually take off into the wind 95% of the time. Okay, visualize the airport environment for your takeoff, how things are going to work with those trees, those buildings, all those things. Crosswind aileron deflection. This is something that's missed a lot in nose wheel airplanes, because this is something you have to do in a tailwheel airplane. Is you basically fly into the wind. You turn into the wind to keep the wind from skipping you across the runway. And if you do it correctly, really you're flying almost the entire takeoff, especially in a crosswind. You're flying the entire takeoff, finding the sweet spot where the wind isn't pushing you to the side and kind of skipping your tires. And then when you lift off, you're kind of releasing those control deflections to then crab into the wind. And now you are going to track center line as you climb out in the takeoff. So those are the big things for takeoff: is crosswind deflection, aileron deflection, crabbing into the wind after you lift off, using your rudder to counteract for some of those movements as your nose pops off. There are things, especially with the left turning tendencies, that you need to do with your pedals to make sure that you're staying coordinated through that entire process and giving yourself the best performance and chance. You'll just have to see those in the airplane. All right, climb. So now you're in that cube of air, okay? So now that air movement and everything is as if you're moving along with it. So there's no performance gain now with the headwind. We're trying to go somewhere. So if we have a tailwind and we're climbing, it's not such a big deal. We're just going with it. What really matters is how that wind is pushing you navigation-wise. So laterally, how it's pushing you, and you correcting for the wind. Those wind corrections can be done with dead reckoning when you're doing your flight planning. If you're doing flight planning with something like ForeFlight, it'll actually take into account all the winds aloft data for your particular flight plan and give you the right headings to fly for those wind correction angles. Okay. So cruise, that big picture thinking of winds aloft, I think we need to think critically with winds in the cruise. This actually goes back a little bit to pre-flight planning, where we think about our altitude selection. You know, if the headwinds are less 3,000 feet lower, and we're not going to get a big performance 4,000 feet lower, whatever. We're not going to get a big performance hit by flying lower or flying higher. We just want to select our best situation. You know, if we can get up to where we have a great tailwind and there's some sort of wind shift there that we just get to cruise along and go super fast, that sounds great to me. If there's some headwinds that we want to avoid at a certain altitude, we can think of that as well. You can get really big picture with course selection, because these air masses, high pressure and low pressure systems, they rotate. Let's see, high pressure rotates to the right and low pressure to the left. Anyway, I'd have to look at a map and then I'd know. But they rotate a certain way. So if you're going to fly a really long cross country, probably in a fairly more high performance, fast moving airplane, sometimes it's actually faster to go around and get the tailwind, go around the entire system and get the tailwind and take the penalty of distance, but actually you're saving up for it in time. So you can think of wind that way as well, as a tool on a much larger scale of an actual weather system. high pressure or low pressure, or however that wind is moving. Mountain flying, the stream analogy, which I already shared, be diligent, get your training in mountain flying. And it's really about the unseen, visualizing, using those things as a tool, avoiding the things that could get you in trouble. And that's mountain flying for you. That could be a whole different podcast. So the approach is you're planning ahead of different sources, obviously getting that automated weather ahead of time, find out what runway you're using. That's going to help you with your traffic pattern entry and everything. You can anticipate those ground speeds, those turns, those crab angles you're going to have to use. So what I see a lot is pilots, the perfect example is when someone's turning from base to final and there's a wind, say a crosswind, and they don't turn all the way back into the wind to crab into it. And then we just end up getting blown off, or they don't stop their turn early to keep that crab. So it's all about anticipating where your heading is going to be to kind of stop there and have a good crab angle to keep that ground track that we talked about, that drawing with a pencil right underneath you. That's important. Again, visualize the airport environment. That's really important. And visualizing how things are moving around that. Now, I think this is really important to point out, because a lot of the times as you grow in experience, especially, you're going to be flying in the places that you don't know. And you almost number one, the thing you need to be thinking about in the pattern is how things are going to move. Like, actually investigate the ground and the buildings and everything. If there's some source you can use ahead of time to do that, that's pretty helpful. But there are some airports that can get pretty tight and crazy if you're not careful with how the wind is moving around. So again, having some sort of exercise or methodology, some visualization to know how the wind is moving throughout the airport, and the environment and the different spots you may be landing on the runway, etc. Okay, so that's the approach. Now, talking about the landing specifically, landing into the wind is something that we do. Kind of depends on the slope of the runway, but most runways are fairly flat. In other words, sometimes you take the tailwind penalty and you'll go downhill, as an example, because going uphill on the takeoff or the landing, going downhill on the landing in this particular case would give you a big penalty. So taking a tailwind on the uphill would be a better choice in some situations. So in other words, we have a headwind because we have less forward energy when we actually land. We can stop faster that way. We won't burn up a ton of runway as we're landing, and tailwinds can be a big problem on that. We actually had a fairly prominent accident here recently in Alaska where the pilots, for whatever reason, picked a runway with the wrong wind that they shouldn't have. This was a passenger aircraft, and they deliberately picked a runway that had pretty good tailwinds, and they went off the end of the runway, and someone lost their life in that accident. So yeah, I mean, it would have been a whole different story if they would have just landed into the wind. Would have been a non-issue. So it is a big deal. So again, anticipate those air movements. You've already done an exercise of visualizing where everything is. Know how your aircraft acts with the wind in each different configuration. So for example, a lot of the times when I'm landing in gusty winds, especially crosswinds, I won't do full flaps, because a gust of wind suddenly can give you an extra bit of performance with a lot of flaps and cause you to bubble up. And then that messes with my ability to be able to hit a spot on my landing. So you really have to know how your airplane is flying in different conditions in the wind, at different speed configurations or angles or flap settings, whatever it is. Okay. Winds, I like to teach kind of a hands-off approach to landing, because if you trim everything up and you get it nice and set up, really the airplane can kind of fly itself down to a landing. But when you're dealing with winds, especially crosswinds or gusty winds, you really do have to be more active on the controls, and you're going to be controlling the airplane more. That's just the way it is. So be ready to be more active in that, and more deliberate and decisive. And what else can I say? authoritative on you getting to pick where the airplane goes, regardless of what the winds are doing. Sometimes that means you might be working the power more. You might be working the flight controls more. Don't go crazy about it. Less is always more, but don't be scared of being the boss and telling your airplane what to do in order to get through some of these more turbulent situations on landing. All right, know your crosswind landings. That's an entirely different subject, but take the opportunity to go out and practice it with an instructor and learn. Don't be afraid of it. Eventually, you're going to be able to get used to it, and almost every landing is a crosswind landing. If you think about it, there's some sort of crosswind going on. So just get used to it. Obviously, you know that there's going to be a limit there to how much crosswinds you can use, and just think about that and be willing to go out and learn it. And then in terms of touching down and in the flare, those last few seconds before you touch down, the airplane can do a lot of funny things at that point. It's really slow. It has the tendency to weather vane. There's not a lot of forward energy left in the airplane, so you can get some funny things happening with wind picking up a wing or pushing the tail if you're in a tail wheel. So just be ready in those instances to be using the rudder more is what it dials down to. Again, there's a whole list of different situations there. You could get really in depth to talk about what the wind does and how to counteract for it. But just know that the wind is going to act a little bit different or feel like it's acting different when you're in that flare and touchdown mode. And then even transitioning to the rollout, you're going to want to roll the ailerons into the wind too if you're in a crosswind, for example. So lots of different things. Then you're going back into those taxi disciplines that we started out with. So I hope that was helpful for you in this podcast. I know I was talking a little fast because I want to get through all the content. We're already a little bit over our 30-minute mark, which I try to stick to. Feel free to comment with a time code on something you found interesting. Maybe you learned something new in this podcast or something you want to know more about. I'm more than willing to continue the conversation in the comments, no matter where you see this podcast. If you enjoyed this podcast, way to give back is to support us by getting into one of our ground schools or our Check Ride Ace. Of course, you're our warriors if you've already been through ground school and all that to pass your written tests, or you don't have a check ride coming up. You are our weekend, not our weekend, but our road warriors to be out there and spread the word about what we do here and suggest our offerings to others. That really helps support the show, helps me grow what I'm doing, helps me hire people to help do some behind the scenes stuff to continue to grow this business. So I really appreciate your support. If not monetarily, I'm not begging at all. Just thank you for being part of this community. I really appreciate all the messages I get. You guys are awesome. I'm really encouraged by the stories I get. I really enjoy talking to you and helping you through different situations that are difficult for you. Don't hesitate to reach out. I love giving advice and helping you through this journey to becoming a pilot, whether for a career or for a hobby. And I get a lot out of it. That's why I do what I do. The money stuff is just to support me and keep doing it and to support my family. So thank you so much for being part of all this. Hope you guys are moving forward, finding the steps and the encouragement you need. And that's it for this episode. And until next time, throttle on.
We sincerely thank you for joining us on AviatorCast. Please subscribe through your favorite podcast service and leave a review. Check out more flight training resources at angleofattack.com. There you can find this podcast, many free aviation training videos, as well as online ground school for private instrument, commercial, and CFI. Got a check ride coming up? Check Ride Ace from Angle of Attack is your ultimate companion, guiding you through the process so you can conquer your big day. Thanks once again for joining us on AviatorCast. Turn left, contact Ground Point Niner.